Today, we are going to discuss the topic, the Introduction to Network Security in Application Layer. Before starting to the network security, the requirement of network security, let me discuss what the application layer is, what are the various functions of application layer, and then we will be moving towards the requirement of the network security in application layer, right? So, first of all, we'll see what the application layer is. Application layer in the OSI model, that is the closest layer to the end user. That means the application layer and the end user can interact directly with the help of some of the application softwares, right? That means that is how the user can interact with the various software applications, right? The application layer programs that are based on the concept of client-server computing, right? So now we'll see what are the various functions that are being performed by the application layers, right? So here these are the list of functions that are being performed by the application layer. Number one, identifying communication partners, a very important function. The application layer identifies the availability of communication partners for an application with data to transmit, right? Number two, it needs to determine whether the resources are available, right? So, determining resource availability, that is the another function of application layer. The application layer determines whether sufficient network resources are available for the requested communication. That means if it is getting a request for the communication, what are the various sources, what are the various resources that are required, whether those resources are available with it. Fine. The next one includes synchronizing communication, which says all the communication occur between the application requires cooperation, which is managed by an application layer. So, identifying communication partners, determining resource availability, synchronizing communication, these are few of the functions. Other functions include network virtual terminal, the various services which are being provided by the application layer. Number one, network virtual terminal. The application layer, it allows a user to log on to a remote host. A user may be remotely available anywhere. To do so, the application layer creates a software emulation of a terminal at the remote host. The user's computer talks to the software terminal, which in turn talks to the host, right? Now, the remote host thinks that it is communicating with one of its own terminals, right? So, it allows the users to log on, right? Number two, file transfer, access and management, also abbreviated as FTAM. An application layer allows a user to access files in a remote computer, to retrieve the files from the computer and to manage files in a remote computer. The file transfer, access and management, FTAM, that defines a hierarchical virtual file in the terms of file structure, file attributes and the kind of operations performed on the files and their attributes, right? So, these are the services of application layers. Other services includes addressing. To obtain communication between client and the server, there is a need for addressing. How to obtain a communication, how to establish a communication. We need to have a concept of addressing over there that is being provided by the application layer. When a client made a request to the server, client made a request to the server. The request contains the server address and its own address, so that server will be able to understand from where it is getting the message, right? The server responds to the client request. The request contains the destination address, that is client address, right? How we achieve this task? To achieve this kind of addressing, we use DNS, right? DNS is used, right? Number two, another service that includes mail services. An application layer provides email forwarding and storage as well. Another service, that is a directory service. An application layer contains a distributed database that provides access for global information about various objects and the services. And at last, we are having authentication. It authenticates the sender or receiver's message or both, right? So these are services of the application layer. Now we move towards need for security. We have seen what functions are there of application layer, what are the various services that application layer is providing. Fine. Now we'll see, during that communication there is a high requirement, high demand for the security. So how to manage the security in the application layer? We'll see that. First of all, we'll see what is the need for security. So here we have some of the adversaries and what is the goal? The most popular one and the obvious one, the students, right? What could be their goal? Just to have a fun snooping on people's email, nothing else, right? Okay, next we have crackers, to test out someone's security system and steal their data, right? Another could be the sales representatives. What could be their goal? To claim to represent all of Europe, not just Andorra. It could be anything, right? Another example we can take for the businessmen, to discover a competitor's strategic marketing plan. Few of the ex-employees could be there. What could be the goal for those employees? To get revenge for being fired. If someone got fired, then that person, with the intention to provide a harm to the organization or to take the revenge for being fired, that can do this, right? Accountant, to embezzle money from a company. Stockbroker, conman, spy, terrorist, and many more are there. Fine. So here we see some of the people who cause security problems, and these are the reasons, these are the goals, or these are the causes why they are doing that. Fine. So how we are going to provide a security? We are having multiple mechanisms for that, right? So first of all, we need to understand what are the various areas, right? The various areas include secrecy, keeping an information out of the hands of unauthorized users. Second, authentication, that means whom you are talking before revealing the sensitive information. Next, we can have non-repudiation, that is signatures. Say customers really placed an order, or someone else was there who has placed an order on behalf of that ex-customer, right? Then integrity control, received message is really sent or there is a integrity breach. So one of the method to provide a security, or one of the most popular method and important method to provide a security, is cryptography. So, in the upcoming slides, I am going to discuss with introduction to cryptography, substitution ciphers, transposition ciphers, one-time padding, and so on. So, one by one we will be discussing. Number one, introduction to cryptography. First of all, we will see a plain text. Plain text means a normal message, a plain text, whatever you are writing, whatever message you are trying to pass to your friend, to your peers, right, that needs to be encrypted, right, so that any other user will not be able to understand what message you are sending to your friends, right. So, we say a plain text is converted into the ciphertext, and then that ciphertext will again be converted into the plain text, right. How it is getting converted into the ciphertext, what is the ciphertext, and how it is again decrypted, and then receiver will get the original message. Here we have many of the encryption methods that will be applicable, that will be applied on the plain text. Then that message, the plain text, will be converted into the ciphertext. Fine. I repeat, plain text is there. Then we will apply some of the encryption method, say E, with the help of an encryption key. With the help of encryption key, encrypted encryption algorithms will be there. Then that message will be converted into the ciphertext. Then this ciphertext again will be decrypted with the same algorithm, right, and will be having another key, decryption key K. Then decryption will take place. Then plain text will be received at the receiver end. The complete process is not known to the sender and the receiver or the other user, right. The encryption model for a symmetric key cipher. We see a passive intruder. What it does? It does not do, it does not provide any harm to the message. It simply listens. A passive intruder, a passive hacker or attacker that simply listens, right? Try to observe the pattern, the messages, the communication, and so on. But if we take the example of active intruder, they can alter the message. You are trying to communicate some of the message to your friends, to your classmates, to your peers, right? What active intruders are doing, or what they can do, they can capture your message and can do some alteration, and that will be transmitted to the receiver, right? We have a Kirchhoff's principle which says all algorithms must be public. All algorithms must be public. Only the keys are secret. The keys with the help of which we are applying some encryption and decryption, that will be secret, right? That will be if it is public, then it will be known to everyone. For example, your email ID. Your email ID is known to everyone, right? But the password is known to you only. Fine. So, what are the encryption methods? We are having substitution ciphers and transposition ciphers. Number 2, transposition ciphers. So, one by one we will be discussing. Number 1, substitution ciphers. In this kind of a cipher technique, each letter is getting replaced by some another letter, right? For example, if we use Caesar cipher, A becomes, in the case of Caesar cipher, A becomes D. A becomes D. That means from Z to C we will be checking, right? So, we can shift by K letters. What is this K? K is the key. K is the key. Monoalphabetic substitution and can be broken down easily with the help of properties of natural languages. How it is working? Okay, next we have transposition ciphers. Here we will be having a key. In this example, I am having a key that is megabuck. Megabuck. This is the key, right? Whatever plain text is there, that will be simply arranged according to the plain text. The plain text is, please transfer $1 million to my Swiss bank account 622. For example, this is the plain text. We have nothing to do. Simply just place this plain text in this order. What is the order? What is the format? The format, it depends on this key. I have written the key over here, megabuck. Then I have written the plain text in the sequence, right? Now, according to the alphabetic order, we'll be having the sequence number, right? Say number 1, A, okay, 1, then B, 2, then C, that is 3. After that, we do not have D over here, so we'll simply skip, and next letter is E. We give a number 4 to E. Then we do not have F. Next is G. So, number 5 will be provided to G. H, I, J, we do not have those numbers. Simply, next number will be given to the next letter, that is K. Then L, M, okay, just skip. Okay, next is what? M. M is given a number 7. At last, we have U. Number 8 is given to the U, right? So, now how to convert? Now start with the sequence number 1. A, F, L, L, S, K, S, O. A, F, L, L, S, K, S, O. Right? In a vertical order. Next is 2. Then start with S. S, E, L, A, W, A, I, A. S, E, L, A, W, A, I, A. Then next is 3. T, O, O, S, and so on. Right? As simple as that. So, that's how this plain text is getting converted into the ciphertext. Right? So, that is about the transposition ciphers. Now, we'll see what are the symmetric key algorithms and how it is working. These use same key for the encryption as well as for the decryption. Right? So, we will be having a discussion on DES, which is very important as far as the university examinations are concerned and the cryptographic methods are concerned. DES, that is Data Encryption Standard. So, in this data encryption standards, we are having multiple steps, and on the basis of those steps, this plain text, a 64-bit plain text, is getting converted into 64-bit ciphertext, right? So, what are the various steps it includes? It includes number 1, initial transposition. Initial transposition, number 1. Then, there are 16 iterations. After performing these 16 iterations with the help of a 56-bit key, here a 32-bit swap will be done, right? After performing swapping, an inverse transposition will take place, and then we will find a 64-bit ciphertext. So let me tell you what a first iteration includes. First iteration, or example of one iteration, what exactly is happening in one iteration, right? So we have divided the bits into two groups, left group and right group, right? So that was a 64-bit plain text. We have divided the 64-bit into 32 and 32, 32 left, 32 right, right? Okay, these bits after division, now we apply a function, a formula over here, li minus 1, then XOR and then some function, right? So what the function is, ri minus 1, that means bits from the right hand side along with the key. Which key? A 56-bit key which we are using, right? Just after performing this function, fine, we get the 32 bits, right 32 bits, right hand side 32 bits, right? And here, because it has gone swapped, right, it has been swapped, so here I am having left 32 bits, it becomes left 32 bits, right? So this is what, this is a detail of one iteration. The same process is getting repeated 16 times, right? Every time this is getting repeated. One iteration to second iteration, third, fourth, up to 16 iteration. The same process will be going on. And then again we will be having a 32-bit swap, fine, and then we will apply a inverse transposition. So what this formula is, what this function is, exactly how it is working, what this meaning is. Here we have our 32 bits, apply an encryption, right, with 16-bit key, so we got 48 bits, right? These bits along with the another side bits, 48 bits, that are being XORed, and then S1, S2, S3, S4, S5, 6, 7, 8, these operations are being performed, right? And then we got this 32-bit, right? So that was the detail of this function, function which we are performing over here. Fine. So what this key is, we have seen that we have used a 56-bit key. There were 16 iterations, right? In all 16 iterations, a different key is used. In starting, 56-bit transposition is applied to the key. In each iteration, key is divided into two 28-bit units, each of which is rotated left by a number of bits depending on the iteration number. Ki, it is derived from this rotated key by applying another 56-bit transposition. A different 48-bit subset of the 56-bit is extracted and permuted on each round. We have seen over here. Fine. So that was about the DES, right? To make it more secure, we are having triple DES. That means instead of 2 times, 3 times we are doing, 3 steps are being followed. That means plain text is getting converted into encrypted ciphertext, and then again decryption, then again encryption. Fine. Okay. So plain text, encrypted text with the help of K1, then with another key, say K2, it is getting decrypted. Again with the help of K1 encrypted. Once it is encrypted, we get the ciphertext C, right? This ciphertext will be decrypted with K1, then encrypted with K2 and again decrypted with K1, and then after decryption we get the plain text. DES key length was short, so it was devised, right? So we can use triple DES. Fine. So multiple algorithms we have. One of the algorithm is a public key algorithm, and in the case of public key algorithm, as the name is indicating, for keeping the keys same at both ends, which is public. Keys had to be protected but to be distributed too. That again is a challenge. So the different keys, what are the basic requirements? Okay, decryption on encrypted plain text, then we'll get the plain text back. Difficult to deduce D from E, and E cannot be broken by a chosen plain text attack. So two keys are used. One is public, used by the others for the encryption. Second is private, which is being used for decryption. The very famous and the very important and popular algorithms we have over here, that is the RSA. In RSA, each user generates a public or private key pair by how it is doing. It has to perform some of the steps which follows. Number one, choose two large primes. Two large prime numbers. Okay, say number one, that is P, and Q. Say typically that is of 1024 bits. Now after choosing two large primes, just compute n. How to compute n? N is equal to P into Q. Then we need to compute Z is equal to P minus 1 multiplied by Q minus 1. Now choose a number relatively prime to Z and we denote it by D. Find E such that E into D is equal to 1 mod Z. Right. So to encrypt a message P, we need to compute C is equal to P raised to the power E mod N, and to decrypt a message C, that is the ciphertext, to decrypt that ciphertext we need to find out a plain text. So it could be computed with the formula C raised to the power D mod N, right. So we can say the public key is E comma N and the private key is G comma N. These are the public key and private keys. After that, we can solve a given problem using the given formulas with RSA algorithm, right. So the authentication protocols are also we have that is being used, which plays a very important role in providing a network security. So the authentication based on a shared secret key and establishing a shared key. For establishing a shared key, we use Diffie-Hellman algorithm, right. So what Diffie-Hellman key exchange says, or this algorithm says, for example, there are two participants are there. One is Alice, another is Bob. They want to communicate with each other. Now we say Alice picks X and Bob picks Y, right. So it is communicating with n comma g raised to the power x mod n. What is the number that is being chosen by Alice? That is x, right? So it will use its key. Okay. Now Bob has picked up a number that is y. So it will send with its key g raised to the power y mod n. Fine. Now Alice will compute g raised to the power y mod n raised to the power x. That is its key mod n. So we can find out g raised to the power xy mod n. Similarly, we see Bob computes this one with its key. So g raised to the power x mod n with y raised to the power y mod n. So here we can see g raised to the power xy mod n. This is a Diffie-Hellman key exchange. How to establish? We have seen. Okay. So Alice is sending with its key, and say Trudy is there, which is, this is an example of man in the middle attack, right? Trudy is there, which has picks z, right? And it has computed with its key g raised to the power z mod n. Now it will compute with this, but what was required? It was required g raised to the power y, because it's trying to communicate with Bob. Alice is trying to communicate with Bob. Fine. When it will receive a message, again it is getting a message from Trudy instead of Alice, right? So that's why you can see a z over here, right? So it will apply its key, so z raised to the power y mod n. So this is the example for the bucket brigade or man in the middle attack. Here these are the references from where I have included the content in my slides. Thank you.